Hello everyone. Today in this video we are going to be learning how to find inverse functions. So we have two different functions here, so we'll do two different examples. The first function is f of x equals negative 8x plus 17 and g of x equals 3 divided by x minus 5. So we're going to be finding inverse functions. And the way we're going to go about this is the first thing we're going to do is we're going to take it out of function notation. And instead of writing f of x, we're going to write it as y. So instead of f of x equals negative 8x plus 17, we're going to get y equals negative 8x plus 17. And then what we're going to do as a second step is we are going to switch the x and the y. So I'm going to rewrite this, but anywhere I see the y, I'm going to write an x, and anywhere I see an x, I'm going to write a y. And then what we want to do is we want to solve for y. So I'm going to get y by itself. So I'm just going to go and kind of do the opposite operation. So instead of adding 17, I'm going to subtract 17 on both sides. And that'll turn to 0 on the right and disappear. And then on the left, we're going to get x minus 17 equals negative 8y. And we got to get rid of that negative 8 so that y is by itself. So the opposite of multiplying is dividing. And that'll divide to 1, so we get 1y, and we'll divide it on the other side. Make sure to divide the entire x minus 17. So then what I'm going to do is on this right side, we're going to have y by itself, but I'm going to go ahead and move it to the left side. So I'm going to switch the right and left sides, and then we're going to have x minus 17 over negative 8. Now, I don't want to leave that negative sign in the bottom, so what I'm going to do is to either you could move it out front, or you can distribute it into the numerator, which is going to be what I'm going to do. So we get y equals negative x plus 17 all over 8. You have to make sure to distribute it to all the different terms in the numerator. And then we have the inverse. Now, I'm not going to leave it like this. I want to write it as the inverse function. So it is function f, so I'm going to use f again, but the inverse notation kind of looks like a negative 1 exponent. It's not actually an exponent, but that's kind of what it looks like. So I'm going to write that as f negative 1 or f inverse of x. And there we have it. Now we're going to do the same thing for the function g. So what I want to do, first step, is I'm going to make g of x y instead. Second step, I'm going to turn the y into x and turn the x into y. And then we're going to go ahead and solve for y again. So I'm going to add 5 to both sides. So we get x plus 5 on the left side equals 3 divided by y on the right. Now, I need to get y by itself. Now it's in the denominator. The way we're going to do this is we're going to multiply both sides by y. I want to get it out of the denominator, multiply it by y on that right side. That'll cancel to 1 and leave us with just 3. And also multiply it on the left side. Now, I'm not actually going to multiply it on the left side because I want to keep it separate from that x plus 5. So that now, as my last step, I can divide that x plus 5 on both sides. And that'll, again, turn to 1 and kind of disappear and leave y by itself and give me y equals 3 divided by x plus 5. And again, I want to write it in function notation, so I'm going to write it back as a function g, but with that inverse notation, which looks like a negative 1 exponent, and we get 3 divided by x plus 5.